So just finishing up page 15, I know you guys should have done this on your own, but remember these points are always listed as X and then Y. So if we substitute them into our equation, they should be true. So we're going to put 8 in for Y here. So we would have 8 is equal to 4, open your parenthesis, put your X in there, just 5 in this case, minus 1. So 8 equals 20 minus 1. Does 8 equal 19? No, it does not equal 19. And you need to show that work? Yes, you do need to show that work. So hopefully you've done more than circle yes and no for these, right? Then here we're saying 39 is equal to 4 times 10 minus 1. So 39 equals 40 minus 1. Does 39 equal 39? That one checks out for sure. So hopefully you've shown that work and you understand how we did that. Page 16 now is where we're gonna start rolling from today. Systems of equations. So we've practiced a little bit with systems of equations, but remember systems of equations are two or more equations with the same variables. This is page 16. Our definition for systems of equations are two or more equations with the same variables. If they did not have the same variables, we would not be able to solve it. Okay? Are we good on that definition? Almost? Two or more equations with the same variables. Remember, variables are the letters, right? So hopefully our vocabulary is broadening. We're remembering these things more and more every day, right? All right, so graphically, the point xy, the solution to a system is the point xy where the two lines, what? Do you remember? Intersect. Excellent. So right where they cross, right where they touch, right where the two lines intersect is the solution to a system graphically. And the solution to a system algebraically is the point xy that makes both equations true. Yep. So it might not make them equal, like it might not say, you know, they might not both equal the same number when you put them in, but it makes both sides of each of those equations equal. So it makes them true. All right,
Here's what I found.
Thank you, Siri. All right, intersecting lines. These lines, you can just kind of make an X. If they intersect, there is one solution. And we always list our solution as an ordered pair, X, Y. parallel lines, remember the very definition of parallel lines are two lines that will never intersect in either direction. So there is no solution. So we always show this kind of like we do undefined. There's no solution if the lines are parallel. So, Grace, if I see your phone out one more time, I'm taking it. What are you playing with? Okay. So I need you to think about this. If we see two lines that are parallel, it means their slopes are what? The same, right? But if our slopes are not the same, that probably means they're intersecting. Because if we have the same line, not only are they parallel, but they also have the same y-intercept. It's like two of the same lines. It's hard to show. They have infinite solutions. So every point on this line intersects with both lines. Okay, so we have one solution, no solution, or infinite solutions. Okay. We have practiced solving systems by graphing already, but just for review's sake, the first thing you're going to do, because sometimes we won't have them in slope-intercept form now, we have to rewrite the equations in slope-intercept form. We are used to graphing from that form, right? So we might have to rewrite the equations first. Then we have to graph the line. I would say we have to graph the lines, right? And finally, identify the solution. Or solutions, I suppose, if it's infinite. So we're gonna get some more practice here. Graphing them. You know, if you like turn your whole body, and that would be great. So here, remember, if it's in y equals mx plus b, our coefficient is our slope, rise over run, and our constant is our y-intercept. So our y-intercept of this first line is what? -8. So I'm going to count down from my origin. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to put a point there because it is on that line, because that's my y-intercept. And then my slope is what? Positive or negative? My slope is positive because what is the coefficient of x? The coefficient is 1. So if I think of this as a fraction, I think of it as 1 over 1. So I'm going up 1 over 1, up 1 over 1, right? And then I have to use a straight edge like your planner or something. You do want to be accurate in these lines. So if you are in need of a straight edge, you don't have something with you. Ruler there. That's not. So once you have graphed the first line, you need to move on and graph the next line. Who can tell me what our y-intercept is of the second line? What's B here? 1. So right on the y-axis, I'm putting a point when y equals 1. And now my slope is negative. So this second slope is -2, but remember I can think of it as -2 over 1. So down 2 over 1. So count down 2 over 1 and put a point. Count down 2 over 1 and put a point. Count down 2 over 1 and put a point. And just for accuracy's sake, I would kind of continue on until you hit the other line. That way you are definitely accurate, just in case your lines don't happen to be straight. And then I'm going to just extend my line here. Make it official, even though we already should have located our solution, right? Our solution is this point of intersection here, right? Here is our solution where they intersect. So what is the x value and what is the y value there? So go kind of draw an arrow up to your x-axis. What does x equal there? Any ideas as to what x equals there? X is +3 there, right? So we're going to, we've already opened our parentheses, hopefully. And we're going to put a 3 here. And what does y equal here? Well, I wouldn't say 5 or 4 because this is below 0. So -1, 2, 3, 4, 5. So -5. So that's how we're going to show our solutions. You have to understand ordered pairs, right? You've got to know how to graph from slope-intercept form, and eventually you may have to, rearrange, but we've been practicing all those things. All right, let's start graphing these two lines. What is my y-intercept here? 9. I know these are up 10, so I'm just going to put a 9 here. And my slope is 1/2. So this is 1 up, 2 to the right. So up 1 over 2. Or 1 down, 2 to the left. So down, 2 to the... So you could keep going on and on. Use your straight edge. You can kind of see where it should be going through the corners. I missed a little bit there, but. All right, then our next y-intercept is 6. 1, 2, 3, 4, 5, 6. So I'm going to put a point there. And here my slope is -1. Remember, this is equal to -1 over 1 or 1 over -1. So this is 1 down, 1 to the right. So 1 down, 1 to the right, 1 down, 1 to the right, or 1 up, 1 to the left. 1 up, 1 to the left, 1 up, 1 to the left. So you see now where you're going to be going through that second line. So once you've graphed your two lines and located where they intersect, you have to figure out your coordinate points. So what is the X value here? Excellent. And the Y value is 8. So that is my solution to those system of equations. So far, so good. Questions on page 16. It's a little new, a little review. All right. So that is what we're going to do. It doesn't look like we have to rearrange anything today, but we're going to start into these. So all of these are graphing. Essentially, through the end, oh yeah, you don't even have to, all right, so we're going to play some whack-a-mole. You've got these here, putting the solutions in. Do you want to walk through page 17? Okay, let's do some more review then. Remember, y equals mx plus b. Here's your y-intercept of the first line. So I'm putting a point there on the y-axis. My slope is 3. If I write that as a fraction, that helps me with 3 up, 1 to the right. So 1, 2, 3 up, 1 to the right. 1, 2, 3 up, 1 to the right. Then I'm going to extend that line. Easy there. And then we're going to do the same thing with the second equation. Here's your y-intercept. Here your slope is -5, which we can write as -5 over 1. So 5 down, 1 to the right. So 1, 2, 3, 4, 5, 1 to the right. You're already on the line there. So you should see right away where you intersect, which is at the point. What does x equal there? Nope. X equals 1 and y is -1. That's where they intersect for number 1. Okay. Should you be pretty quick at this? Yes, fairly quick at this, I would say, because this is review. Any observations about this? No, should we just plot them? All right, here's 3. Here's my slope. I'm going down 4. 1, 2, 3, 4 over 3. 1, 2, 3. Any 2 points allow me to make a line. Here, I'm at 1. My slope is -4/3, so I'm going down. 1, 2, 3, 4 over 3. 1, 2, 3. Any 2 points allow me to make a line. What do you notice? They're parallel, right? The slopes are the same. So here we have no solution. They do not ever intersect. Fair? All right. Number 3, our first y-intercept is 3. Down 1 over 2. Down 1 over 2. Or up 1, left 2. Either way. Now our next y-intercept is -1. So I'm starting there, but I'm going down 5. And I notice right away I can't. So remember, -5/2 is equal to 5 over -2. So this is 5 up, 2 left. So 1, 2, 3, 4, 5 over 2. Do you see where it's going to go through? So it is very important that you understand your directions, how negative slopes look, your equivalency with negative rational numbers. So here, what's my x value of this point? Look down to the x value first. So we have -2 over to the y value, which is 4. So that's how I would do number 3. And number 4, -2. A slope of 2 over 1 is of 2 is the same as a slope of 2 over 1. So 2 up, 1 right. 1, 2 over 1, 1, 2 over 1, 1, 2 over 1, or this is the same as -2 over -1, so down 2, left 1. And then here, y is 2 here. And then up 2 over 3. So you can see right away where it's going to intersect. Please do draw your second line though. This is the point 3, 4. That's all you have to do for these. You've got about 15 minutes. So I would say you've got lots of time to start whack-a-mole. See which mole you get.
Really annoying mole. You're in the middle. Why do they have to be on the line?
And then you're going to include your solution here. So plot this line, plot this line. Be careful, some of it is hard to see, like don't forget your signs. Here it's 1/2. Here it's 3/4. So let's down here, right? Our slope is 3/4 for that bottom one. That's nearly impossible to see, I feel like. And then go ahead and keep moving on to whack-a-mole 2 after you finish whack-a-mole 1. And these look okay. That first one is 1/4. All right, guys. Practice, practice, practice. Make sure you practice now. You got about 14 minutes now.